can ignore the mess. I kind of threw this together last minute, but
What?
I'm gonna try and sort of re-explain what Professor Zhao has been talking about with the essential functions, because what the attempt is to lay a baseline for whenever you get to derivatives, which you don't have to worry about right now. Those of you who have taken calculus will know what know what I'm talking about. If not, you'll have heard the term before. Don't worry about it. That's next chapter. So what these equations are the ways that you will relate your base functions and derivative functions once we get to further chapters. So I'm going to do, rather than just giving you some equations, try and show you how these relate to each other in a format that might be better understood. So, to begin, we are going to start with, I'm hoping you can see this, the addition.
Okay, I see.
And I'm just going to do one at a time. And I'm hoping that this will be helpful. If it is, let me know in the group me. I will make more of these. I realize that this is really difficult to see. We'll figure it out. I will write bigger. So, the addition function is whenever you have function f of x.
Okay, that's good.
Plus.
All right. Okay.
G of x, which can also be written.
I think we're going to start a new.
F plus G of x. Now I am going to assume that you know what we're talking about.
A new section 1.3.
That they're just saying this function and that the actual letter doesn't matter as long as it's consistent. That whatever, like say I say f of x equals the square root of x minus 2.
So
then
section 1.3.
It will always be the square root of x minus 2 for this problem. I can't go later on in the equation and say that, oh yeah, by the way, I meant f of x equals just regular square root of x. I'd have to rework everything. But say I need another equation, I'm not going to use f of x for that. I'm going to use g of x for that. And I'm going to go ahead and, based off a practice problem within the book that I'm going to be using to explain, I'm going to go ahead and define what g of x is. Give me one moment. Lost my page. Here we go. So g of x, for the sake of me showing you guys,
So we're going to do the
equal. It's just going to equal square root of x.
units
X
of
being
a function.
number we decide to put in. And g of x being square root 2 minus x.
So first up,
basically we're going to
discuss the called
the addition
definition.
function is whenever we try and add these two together, we're going to use it to find what domain
Turn to page
actually be available
25.
once we finish with these two functions. So to start, we need to figure out.
You see on page 25, you have the definition number 1.
Each of these equations.
Suppose f of x is defined
of square root of
when x is near the number a. This means that f is defined on some open interval that contains a, except possibly at a itself. Then we write, let me give you a concrete example. Okay, this is on page 25.
gonna write this in a different color so that it's easier to see. Here, I'm gonna do a
So
little.
I will write something like this.
Make sure it is a little bit easier for me.
X goes to say
Bear with me.
5
Doing this all
and x squared, and the number here is 25.
So whenever I'm writing all of this out.
So what does this mean?
F of x is blue, g of x is red. So f of x is square root.
If you compare this one with the notation on page 25,
underneath it is going to be,
then you see in this equation here, this is your f of x,
to positive infinity,
and this is your number a,
so
and this is your limit
I'm hoping
factor f.
that is
Okay.
legible.
So what that means now is
It's not looking like it is.
you say the limit of f of x as x approaches a equals f. So in this concrete example, is the limit of x squared. X squared is your function f of x. So the limit of x squared when x approaches 5 is 25. So 5 is the number a in that abstract definition, and 25 is the limit of L, the number L. Okay? So you have so you read this equation as follows. The limit of x squared when x approaches 5 is 25.
So it can go.
Then of course, this is just simply the definition. When next the natural question is, when give you any concrete function f of x and the number a, can you find the limit? So in this case, it's easy. X squared when x intuitively, what means when x gets closer and closer to number 5, then x squared would get closer and closer to the number 25. Isn't that right? That's intuitively you can see it. So this is example, and that's why. So this is what the answer for this. If this is the function, this is the number a, then you know the result is 25. But then the general definition is x goes to a, okay, and the f of x. If when x approaches gets closer and closer to a, arbitrarily close, then f of x will get arbitrarily close to what? Number L. Then you say the f of x, the limit of f of x when x approaches a is what? All right. So that is this one here. Now, this is the intuitive definition, and we will only use this definition. There is a more rigorous definition at the end of this. Yeah, on page 31, if you turn to page 31, there is the precise definition of the limit. We're not going to use that, but you just need to know it. This is just an intuitive one. You can see that on page 25 it says the limit of f of x as x approaches a equals L. If we can make the values of f of x arbitrarily close to L, as close to L as we like, by taking x to be sufficiently close to a. Okay. So that is intuitively. Let me show you another by one. I think there is a diagram in the one.
Whenever you put these two equations together, you are going to look for the domain, which is what you will use later to help relate between your derivative and your non-derivative. And so you will get a domain represented by the capital D.
Yeah, let me use this example, figure 1 on page 25.
Add these together,
to show you
You're going to look for
the function limit
because
right
later
here.
on you'll use derivatives to
You see,
actually push them
when
together.
x,
your
so the
domain
number
is going to equal
A is number 2 here.
anything between. Red's a bad color to use.
Okay. So now x approaches can go from either side, on two sides, right? Go from the left or from the right.
It is going to have a square
Okay.
in it because
So when x goes to 2, from the left, you see the curve has a trend. We're approaching this point. Isn't that right?
long story short, I know it's a 10-minute
Then you
video,
found the what?
but I applied
From the right-hand side,
all this,
the curve will
basically
has the trend
to
going downward,
function
approaching this point.
to relate later on with the
So
derivative.
either way, you see a clear trend
And so
intuitively,
two
geometrically, that
equations and
the
GFX,
curve
whenever you add
will
them together,
converge
assuming it's the
to
viable
this
domain,
one point
you actually look at
when x approaches
specific answer, because you can actually
number
put
2
them
from
together.
both sides.
So
Isn't that right? You
you'll
can see it
those,
clearly.
you'll find
Okay?
a viable domain.
So that's the picture. We
And
can
then once
sketch
you do
the
that,
picture
later on,
something like
you'll
this.
find the derivative of these.
So this is the point.
And then
This is
you'll
2.
apply that to get a number in the
So
end. You'll use your domain.
X approaches 2 from the left-hand side. So get closer and closer, you get this point to get closer and closer.
I will gladly help.
Isn't that right?
If this was helpful,
X gets closer
go over
and
subtraction.
closer to 2 on the left-hand side, and the point will converge to this point. Isn't that right?